Now, the second one right here has 9999. So
it can be either or. It can be adding 0 or
well,
by 1.
I asked Miss Goodman about this, and we disagree on this. And I've got to check it out to see what the actual rules are. But to me, this is neither an arithmetic or a geometric sequence. Neither. Yeah, it's just the same number over and over again. So if I had to say, I'd say that was a neither. Because you're not adding anything, you're not multiplying anything to get from it. You could argue that you're adding 0 and multiplying by 1, but I mean, really, we're gonna get into that? No way. Like, that makes no sense.
Did she think it's a geometric?
She told me it could be either. I say it's neither because that's just it just seems to me like a dumb way of doing it. All right.
Like, why would you need that?
Exactly. Right. Exactly. So for number 2, there's a neither. Now, for the third one here, part C, I go 4, -2, 1, -1/2. Yeah, you can kind of tell that it's going to be a geometric sequence because we're not adding the same thing over and over again. But we still have to like identify and show how it works. So let's do that. Let's do that now, please. So let's move on to part C here. And we kind of feel that it's going to be arithmetic. So let's test to see if it's arithmetic or not. And the way we can test to see if it's arithmetic is if we find a common ratio, an R, that is the same between 2 or 3 different numbers, then we'll be in great shape. So R, does anybody know how to find R? How do we figure out what R is? We take a term. Yeah, we're divided by the previous term. So I'm going to take R sub n, and I'm going to divide it by R sub n minus 1. So any term divided by the term that came right before it. So if we take -2, so R is equal to -2, that's this term, divided by the term that came right before it, which is that 4, then we can say that we have -2 divided by 4, which gives us an R equal to -1/2. So we figured out that R is equal to 1/2. Now let's check another point, another 2 sets of numbers, to make sure that it's actually geometric. So, and that's what this really means. If you're checking to see if this is arithmetic or geometric, you have to check more than just one point. So now let's take this one over here, -1/2. So R is equal to -1/2 divided by the term that came right before it, which was 1. So what's -1/2 divided by 1? -1/2. Hey, look at that. They're the same. It's a common ratio. That means this is it's a geometric sequence right there. Now, let's take a look at this very last one here, D. I go from 1 to 1 to 2 to 3 to 4 to 8. Am I adding anything to get from 1 to 1?
No.
Am I multiplying anything to get from 1 to 1? No. If you see 2 numbers that are identical in a sequence and they're right next to each other, just like up here when you had 2 numbers that were identical to each other and they're right next to each other, it's going to be a neither. If you see that same number showing up right next to another number, right next to the same number, it's going to be a neither. So this one here, I can add 1, I can add 1, I can add 1, but then, oh, I add 4. Not the same common difference. I multiply by 1, I multiply by 2, I multiply by 3 halves, I multiply by 4/3. Ugh, that does not have a common ratio. So this one's a neither, this one's a neither. Are there any questions? No? All right. Let's keep on going then. So for this next problem, problem 2, is I have a sequence that's defined. My sequence is defined as u sub n is equal to 6 times 1/2 to the n minus 1. So this u sub n, that's called the nth term. So this is the nth term equation that we're looking at here. So let's write it out. U sub n, and that's also the same thing as a sub n, which I've also used, is equal to 1/2, 6 times 1/2 to the n minus 1, right there. So now let's take this and prove that the sequence is geometric. Prove that the sequence is geometric. Well, proving that the sequence is geometric just means that I write out the sequence find the common ratio, prove that it has common ratio, and that shows me that it's geometric. So what's u sub 1 here? It's going to be 6 times 1/2 to the 1 minus 1. That means u sub 1 is equal to 6 times 1/2 to the 0 power. That means u sub 1 is equal to 6 times 1. U sub 1 is equal to 6. So there's my first term. Let's figure out u sub 2. U sub 2 is equal to 6 times 1/2 times 1 minus 2. Oh, sorry, 2 minus 1. It's n minus 1 always. So u sub 2 is equal to 6 times 1/2 to the first power. That's u sub 2 is equal to 6 times 1/2. U sub 2 is equal to 3. So I have 6, I have 3. Let's figure out what u sub 3 is. U sub 3, yes sir?
U sub 1, so in the end term equation, the 6 is A1, right?
Yes sir, it is.
So we have to go ahead and do that, and we just take A1 right there.
No, that's absolutely correct. You could just take that A1 to be right there.
Okay.
I'm going through this as if I didn't know that this equation tells me everything that I need to know.
Okay.
So I'm just kind of going through it blindly. Let's figure out what u sub 3 is. U sub 3 is going to be 6 times 1/2 to the 3 minus 1. U sub 3 is equal to 6 times 1/2 squared. U sub 3 is equal to 6 to the 1 times 1/4. U sub 3 is equal to 6 over 4. U sub 3 is equal to 3/2. So now I have a little bit of a sequence here I can write out. I can say 6, 3, 3/2. And now this is my sequence, and it keeps going. So I can take these numbers now and figure out what my common ratio is. R is going to be equal to any term divided by the previous term. 3 divided by 6. R equals 1/2. So I do this one. Now I can take another set. R is equal to 3 over 2 divided by 3. And when you work this out, you'll discover that R is equal to 1/2 again. So now, because I have a common ratio, I know my sequence is geometric. It's geometric sequence. And that's what proving this stuff really looks like. So when I ask you to prove that a sequence is geometric or arithmetic, that's what it is that I'm looking for you to do. I'm looking for you to go through and show me the sequence, show me that it has a common ratio, or show me that it has a common difference D. All right. So that takes care of number 2A. So now, oh, hey, look at that. Find u sub 1 and R. Oh, my word, look at that. I already have u sub 1. There's u sub 1. I already have my R. It's equal to 1/2. So in order to prove this problem, I had to solve part B of it. So I've already got part A, and I already have part B. The last thing is to find the 16th term. So find the 16th term. Well, that just means find u sub 16. So u sub 16 is equal to, I'm going to look back at my equation I wrote out before. Or I'm sorry, the equation that I was given right here. So u sub 16 is going to be equal to 6 times 1/2 to the 16 minus 1. U sub 16 is equal to 6 times 1/2 to the 15th power. That's going to be u sub 16 is equal to 6 divided by 2 to to the 15th. And you can put this into your calculator right here, and it should work out pretty well for you. So let's check it out here on our handy-dandy calculating device. I'm going to say 6 times 0.5 raised to the 15th power. Ba-da-ba-da. Oh, sorry, you're right. 6